Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are going to be taking a look at the planet Mercury. We will take a general look at the smallest planet in the solar system, but we are going to be looking at Mercury in particular because of its greatest elongation coming up on the 19th of August. So we're here moving backwards in time so that we can catch sunrise on the 19th. And here we go. There is Mercury. It's nice and clear. It's reasonably high above the horizon. This is one of the best occasions that we'll get to take a look at Mercury. It never rises particularly high in the sky and it's not quite as bright as some of the other planets, but it's in a reasonably good position far from the sun here. We also have Venus, Jupiter and Saturn in the sky, so we've got quite a lot of the visible planets all visible here at the same time. We can see here moving back in time how close and Jupiter and Venus got together, and we can see the moon passing by all of these planets as well. But we can also see that as we move forward from the 19th, Mercury gets closer and closer to the horizon at the same time. But we can also see that it's getting darker at the same time. As we move through August and into September, we're going to be moving away from the solstice even more. We're going to be moving closer and closer to the autumnal equinox. We can see that Mercury does get a little bit brighter as we move into the future. So even though it isn't in the sky for as long, and even though it won't get quite as far away from the sun in the sky, it does look brighter, and that does make it easier to see. We can see it's still visible there as we get into September, but we can see here we are after the greatest elongation, but we're later in the morning when Mercury will still be visible into the future, but it disappears even before its greatest elongation at that time. So Mercury, because it is so small and so close to the sun, when we're looking at a half Mercury, not much of the planet is illuminated and it's not particularly close to us, so it's not particularly bright in the sky. We can see this nice half Mercury here on the 19th, or at least nearly a half Mercury. We'll move through the days. There it looks exactly a half on the 21st. So we know that Mercury is at its greatest elongation because it must be forming something like a 90-degree angle with the Earth-Sun system for us to see this with the sun illuminating half of it, and exactly half of it. We can see as we keep moving into the future, Mercury gets more full. We're seeing more of Mercury, more of its illuminated face is visible to us, and that increased illuminated surface area means that Mercury is reflecting more light back to us. So even though it's not getting as far from the sun in the sky, it is brighter, and that's going to keep it visible far longer and make it a little bit easier to see. We can see that happening with the magnitude numbers up here. So Mercury's magnitude there is -1. If we move back towards its opposition, we can see, or back towards its greatest elongation, we can see that number dropping down. If we take a look at the reduced or adjusted magnitude, we can see it's there at 0.65, reduced by 5, we'll say 5 atmospheres, because it's nice and high in the sky. As we start moving forward again, we can see that because its brightness is going up so much, even though the amount of air masses extincting it are also going up, and they're changing because time is moving forward, we'll say 12 and a bit, Mercury is reduced to 0.3 instead of 0.65. because we're reducing from a much higher magnitude. So that's part of what's keeping Mercury more visible and making it easier to see. If we move back to the greatest elongation, which the date I saw for the greatest elongation was the 19th, even though Mercury looks more like a half to me when we're up to the 21st. But we'll stick with the official numbers that I got. So we can see Mercury's magnitude there is just in the negative at -0.02. As we move forward, and it's extincted by 7 air masses because it's not that high in the sky really. If we keep moving forward, we'll see that even though the amount of air masses that are blocking it out get much higher, we can see its magnitude gets much higher as well, to -1.19 there on the 30th of August. So Mercury's variation even though it's at its furthest on a particular date, it's not going to be as bright on that date. And we can see if we move before the greatest elongation that Mercury gets even fainter. I'll pull back a little bit here. We can't actually see it without some sort of assistance, I don't think. So we'll move forward a tiny bit more. There we go. So here we are just on the 14th, so really only a few days before the greatest elongation. We'll get it to 12 air masses and it's reduced to 2.55 magnitude from 0.87, not even in the negatives, and negative numbers are brighter. Mercury here, because we're before the greatest elongation, and it's the greatest western elongation, which is why we're seeing it in the east at morning time, we can see it's only a tiny crescent there. Even though it is closer to us, so much more of it is in darkness that we're not seeing it as bright in the sky. And we can see that as we move forward. Mercury seems to be getting further away from us as it gets fuller, and that's because it is curving back around the sun. To make a very quick comparison with Venus, it will take longer, but Venus, even though it rotates in retrograde, it still orbits the same way as Mercury and all of the other planets. So we can see here Venus past its greatest elongation, looking more full, and if we keep moving forward, it will keep moving away from us and keep getting fuller. We'll need to move backwards in time for Venus to appear less full, for Venus to wane, coming closer and closer to a half and coming closer to us. And we can see that the magnitude of Venus does change here as well, but Venus's magnitude is going down as Venus goes away from us. Not by very much, but by a little. Venus's magnitude increases as it gets closer to us. So Venus's brightness behaves a little bit differently. The relationship between Venus's brightness, glad those changed colour, the relationship between Venus's brightness and how much of it is full and its distance from the Earth is pretty much the opposite of Mercury. We can see Venus there at its greatest elongation being -4, -4.3, so incredibly bright. And if we keep moving backwards, that number keeps increasing because Venus is getting so much closer to us. And Venus does get quite close to us. There it is at -4.74. The opposite happens with Mercury. That's partly due to Venus's atmosphere. Venus's atmosphere is very reflective, so even a small amount of it reflecting light is going to reflect quite a lot of light. But it's also because the distances involved are greater. Venus gets much closer to us when it's at its closest approach, and it gets much, much further from us when it's at its furthest. Mercury doesn't make as much of a difference. It's closer to us, of course, when it's on our side of the sun, and further from us when it's on the opposite side of the sun. But the difference isn't as great between those points as the different points in Venus's orbit. The amount of Mercury's surface getting illuminated also makes a much bigger difference to how much light is getting reflected back to us. It's not a very reflective surface, so we do need quite a lot of it to reflect a lot of light. And we can see that reflected in the numbers up there. The same will happen when Mercury... the same will happen when Mercury is at its greatest western elongation, but it's going to take a little bit of time for that to happen, for Mercury to get to that point. Because Mercury takes 88 days to orbit the sun, it will take 44 days, give or take, for Mercury to come all the way around to its opposite greatest elongation. And if we come back to here, we can see that happening. There's Mercury reaching its greatest elongation on the 19th, and you can see that that's the furthest it gets from the sun. We're moving backwards in time there, we'll move forwards instead, and Mercury comes round to its greatest western elongation. You can see there quite a bit into the future, so we're through there to the 2nd of November is when Mercury will be at its greatest eastern elongation, which means we'll see it in the west, except that we probably won't. So we can see that the angle there at sunset is pretty shallow. The ecliptic is pretty low there as the sun is setting, so Mercury isn't even visible in the sky. We can also see that the sun is significantly lower because we're all the way into winter. Traveling all the way out to the other side, Mercury is still the same distance out from the sun. The size of its orbit hasn't changed, and Mercury isn't particularly eccentric. In terms of eccentricity, Mercury's orbit isn't particularly eccentric, and that means it's not particularly elliptical. Even though all planets have elliptical orbits, none of them are particularly elliptical, at least not in our solar system. Not as elliptical as objects like comets, for example. All of the planets have much more subtle eccentricities than comets, and that's the same for Mercury. I don't know if its eccentricity is listed anywhere on the site, but its distance to the sun doesn't change particularly greatly over the course of its orbit. So we know that it's going to be about the same distance out from the sun, whichever elongation we catch, but the angle that the ecliptic is making with the horizon is so different. Here in August, on August 19th in this case, it's so much higher, the angle is so much steeper than it will be for sunset once we get through to the very beginning of November. So how visible Mercury is in the sky changes drastically from month to month. When its elongation is actually happening matters a lot. So this one is particularly good. It looks like we're going to get a reasonable view of Mercury on August 19th. I hope that you get to see Mercury, and I hope that you enjoyed this video. If you did, please do like it. If you like this kind of content, then please subscribe to my YouTube channel. And if you would like to read some of this information, you can do so on my website, queevianscontent.ie. So thank you very much for watching, and hopefully I'll see you back here next time.